Kia ora tēnā tātou katoa. My name's Shane Clark. I'm the General Manager here at Neuralite, New Zealand's leading waterproof membrane supplier. I'm here today with Peter Mills, our Technical Advisor, and today's topic is around cost-conscious tanking solutions. Sorry, excuse me. Right, so yeah, today's topic is cost-conscious below-ground tanking solutions without compromising quality or performance. This webinar is the same structures as the previous 43 we've done, and which are all available on our website. So this goes for about 30 minutes. It's worth about 5 NZIA, no, it's definitely worth exactly 5 NZIA CPD points. And towards the end, we'll have Q&A. So there'll be a survey that pops up at the end, so don't leave immediately. If you wait a minute or two, the survey will pop up. You can get those points there. So today's key message is about how we can still achieve high performance tanking solution at a common sense price point. So we're talking about that Goldilocks zone. So today, Peter and I, we're just going to cover a basic what we think is tanking, our definition of it, what it includes, how we select the right system. We're going to include a case study that highlights the savings around time and money that we're able to achieve by engaging with the designer nice and early. We're then actually going to finish up with a live demonstration. So I do appreciate you guys' feedback from these webinars and what you do like. So the last one we do a live demonstration of an installation, and we've got another mock-up here to show you how the tanking and that works. And like I mentioned, there's going to be a Q&A towards the end there, so feel free to engage in the webinar and pop your questions into the Q&A section at the bottom. If we don't get through all the questions, that's okay. They'll all come through in the transcript that everyone who's registered here today will get. So that's us, that's our webinar. Let's kick off, keep everyone engaged. We'll start off with the first poll. So basically, on a scale of 1 to 10, how important to you is the tanking of a building? So let that run for a couple of seconds. Cool, what we got there? So yeah, most of us think it's quite high on the list. It's quite high. We would consider it a 10 for the type of buildings that we're involved with.
Yep.
The other reason we consider it a 10 is that you really only get one shot at your tanking. Remedial tanking is not fun or economical. Right, we'll kick into the PowerPoint. Thanks, Jen. Hey, Peter, how you going?
Yeah, I'm good, man. I think I'll start doing some talking now. I think it's good for us to explain what tanking is, what the main 4 approaches to tanking are, and what the levels of tanking are. To start off with, what is tanking? The British definition is it's a system of below ground waterproofing. More to that, it's a system that has to put up with constant water pressure. It's very different to roofing waterproofing, where roof waterproofing will just have rain and maybe some standing water. Tanking often has constant pressure on it, trying to get its way into the system. So the goal of it is to keep the structure dry and to not let water get into the building and cause damage.
Cool. So by our definition, what we're using here, there's a couple of things we're looking for, right? You just covered the water protection.
Yep.
We're talking about conditions as well.
Yep. So it has to last through the conditions, whether you're in an area like Rotorua, where you've got volcanic soils or gases. It also has to be robust. So common sense site conditions, you've got steel that goes in or other trades that will be interacting with the system. So it needs to be robust enough for that. And it actually needs to be repairable if the extreme happens. And I guess a final point for us is that it should also be an integrated solution. So it's not just waterproofing, it's also putting in the insulation factor.
Oh, so we're going to touch more on that later on, aren't we, about integrated solutions?
Yep.
Quite clever, I think. Cool. Go to the next slide there, Jim.
Yeah.
So there are a couple of approaches to tanking. We've got our favourites. Do you want to run through these, Pete?
Yeah. So from left to right, you've got internal waterproofing tanking. These are things like internal coatings, or wet wall systems. So the structure is still allowed to get wet, but it's managed in such a way that you're not causing damage to the contents of the building. Then your second one is concrete additive. These are things like your Zypex, where you've got a chemical added to the concrete before it's poured, so that you're trying to make sure that the structure doesn't get wet, nor the contents of the building. Then you've got unbonded membranes. These are sheet membrane systems that are hung in place, so no water is allowed to get through to the structure, etc. But this is a sheet on the exterior of the building, and it primarily relies on pressure to keep it in place. And then finally, you've got our favorite and personal favorite is fully bonded membranes, where they are adhered to the structure, so that if anything happens to the site conditions, the membrane will stay stuck to the building and will remain intact.
Cool. And I think just before we go to the next slide, I think we've got a poll here as well. We want trying to hear back from the viewers there. What's your favourite approach to tanking? Poll there.
Don't let our favourite bias you.
Yeah, and if you're unsure, I mean, you're unsure, right? So we're all here to learn. So it's also a valid answer. So let that run for a second. Oh, what have we got there?
Interesting.
Yeah. Good stuff. All right. Cheers, Jen. Thanks. Go to the next slide.
So with this one, we've got 3 levels of protection that we look at Neuralite. The most basic is damp proofing, where you're not dealing with water ingress, you're dealing with dampness. Primary use cases for this will be there's a building that's well above the water table, but there might just be one wall that needs a bit of something and the rest of it is all damp proofing. So you'd have maybe one wall that's tanked. In the middle, you've got waterproofing, where you might have your building interacting with the water table, or it's cut a bit deep, or you think there might be flood risk. So then you'll be putting 4 walls and the floor with a tanking membrane. And then finally, you've got watertight, and these are the serious solutions where you've got things like reclaimed land. You might be at the edge of a waterfront. You might be several stories below ground. Constant pressure is being placed on the membrane for water ingress.
Constantly in the water, yeah?
Yeah, that's right.
Yeah. Cool. So you've got an example here of one of our systems, I guess?
Yep. So this is an example of fully bonded positive side waterproofing. This is going on the exterior of the structure. This is our Neuroply 3PT and 3PTM system. So 3PT is fully bonded post-applied to the concrete, while 3PTM is pre-applied, before and after. And there's a backfill protection sheet there to improve the robustness and drainage.
Our next system.
Yep. This is very similar. This is also post-applied system in that regard anyway. It's a self-adhesive membrane. So this is Bitchathene 3000. It differs from the previous one we showed you in that there is no flame application of this system. It's all self-adhesive.
And by post-applied, we're meaning that it's applied after the concrete structure's in place, right?
That's correct. Yep.
Yeah. Okay.
So this one here is pre-proof. This is often used in those watertight situations we talked about earlier. This is a pre-applied system, so it's in the name pre-proof. This goes in before any concrete. It's laid to forms. As you can see, the white membrane all over the walls of this photo. And then what will happen is the concrete walls will be poured against that, and then it gets an adhesive in the membrane, sticks to the concrete, making sure that it's fully bonded.
Okay. It's in the name, right? Pre-proof.
Pre-proof. Yeah.
Yeah. Nice. So you mentioned integrated in one of the first slides there. I think were you going to announce this?
So this is the Neurotherm XPS Combi board. This is a combination drainage and insulation board. There are grooves in it to facilitate drainage. It has a high compressive strength to protect the membrane, and then it also has that insulation factor of, I think it's 2.6 roughly for this 80mm board. This is part of how we're able to deliver cost-sensible solutions. The XPS board is cost-effective, and the NeurApply 3PT system is cost-effective as well.
Nice. Where are we up to? Next slide there. Actually, we've got a couple of questions coming in already, which is great. Some of them about the combi board. What we'll do is we'll just chuck the combi board TDS, the data sheet, into the chat. So a link there if anyone wants to grab that up in there.
I think I might preempt a question right now by saying that the combi board has good drainage, but in a more heavy duty tanking situation where you need a lot of drainage, it can be used in combination with the NeuroDrain that you saw in the previous slide.
Excellent. Right, I think we're up to the next our next phase here. We're going to talk about how do we select the right system. So we don't want to overcook it. We really want to hit that Goldilocks zone. So what are sort of the parameters for us if we want to assist in selecting the right system?
So I guess the key thing to selecting the right system is to getting in touch with us early. The reality is that true value engineering occurs early in the design stage. When a specifier gets in touch with a Neuralite rep, we will be asking questions such as, what is the geotech report? What's the soil condition like? Where's the water table? Is there any volcanic, salts in the soil? Is there gases that we have to be aware of? Is there contamination? We'll ask for sections, topography, all of that sort of thing. And based off of that information early in the design stage, we'll give an accurate suggestion of what system is going to best suit not only the conditions, but the design of the site as well.
Oh, nice. So you've got a bit of a case study there, I believe. So to tell how that came for us once.
Yeah, so it's possible to over specify a system, and I think that's part of where we are able to come in quite useful. The example that I've got for you here, if we change to the next slide, this is a high-end residential building in a sandy kind of sea area. Obviously, with these kind of buildings, you really want to make sure that there's no water ingress. So initially, the pre-proof system was specified. This is a system that does up to 60 meters of water pressure head. So it's a really heavy-duty system. But in this case, the water table was well below the structure. So it was quite overkill. So what our suggestion to the specifier is to specify NeurApply 3PT and 3PTM instead. Still fully bonded membranes, but not rated to such a heavy duty level and therefore more cost effective. So if we go to the next slide, you can see the site conditions, right? There's very sandy soil, very well drained, and the 3PTM is in there ready to have the concrete poured against it.
I guess the other thing about the robustness and specific to the site there with a lot of sand about the original system that was specified relies on self-adhesive laps. So lots of cleaning and sweeping and whatnot, whereas the Torch-On system where the laps are welded is a lot more forgiving to a little bit of sand.
Yeah. Fines can be a problem.
Right? Yeah. Okay. Cool. Well, thanks for that little case study, Pete. And
no problem.
Yeah, how we can suggest the best system for this situation. Mm-hmm. So what we're going to do now is we're going to go live, hopefully, to our in situ demonstration. So we'll pop out there and we'll just run through this. We good to go? Right, okay, so let's just imagine we have a concrete structure here and we have the coming out onto the earth below. We have our concrete wall up here. And while the slab was poured, we used 3PTM, which was in the slab. So this has actually got a mineral surface on the other side that's stuck to the concrete. It's then been primed with a bitumen primer, and we've actually pre-installed the bitumen fillet at this 90-degree transition. We don't want the membrane transitioning too sharp. So Rod and Steve, thanks to the magic of television, are going to install the system basically as it's detailed, as it's specified. So we're using Neuraply 3PT, and this version is a self-adhesive version. So they put in what we call a reinforcement strip in that transition. So the reinforcement strip has to go a minimum of 100 mil each way from the transition. So we're lucky in this case, we're using the self-adhesive version. We're not having to use a flame. We're able to apply it to the pre-primed structure. Hopefully you can see there how that fillet creates that nice smooth transition. And then they're going to apply a second reinforcement to the external angle here, where we have a radius corner. So we've removed any rough edges or sharp corners and whatnot. So we're going to apply another reinforcement strip to that. So essentially this tanking system is, I guess, double layer where it matters, all the transitions, corners, etc. But for the majority of the structure, it is a single layer. That's just going to lap down onto the existing membrane that was cast into the slab pour. So we've got a full waterproof envelope all the way around the structure. And the next step is to apply, what you call the main sheet or the build sheet, which in this case is going to be done in one piece simply because we've got a small section, but it can be done in multiple pieces if we've got a particularly high lift. Again, just to reinforce it, this is a 3mm thick bitumen sheet. It's got 180 grams of polyester reinforcement for it. Quite a robust system. I did see a question in the Q&A that came up that I can answer now. It says, what's the certification for this system? This system is CodeMark certified. We find that probably the highest level of compliance we've got in New Zealand, and it's accepted by councils. It must be accepted by councils. Great job, guys. 150 mil downturn. All rolled in because people are watching. Now we're going to sort of illustrate our backfill protection, insulation, and drainage layer all in one. So the next step is we're going to install the combi board up against the membrane.
Shane, I saw another question that we can answer right now. Someone asked how the water gets to the coil drain. That's through the combi board's
so to install
channels.
The combi board, there's a couple of ways. One, you can actually get the apprentice just to hold it there before it's backfilled. Another way to do it is to use what we call sticky nails. So these are a self-adhesive fixing. It's simply just pressed onto the membrane as required. And they're just there to provide a temporary fix before the backfill goes in. And then the combi board is actually just simply offered up to the membrane and pushed on. So we're bringing the drainage, insulation, and backfill protection down the wall onto the footing, and then down to the face of the footing as well. So it's all very well just having the product to do the job, but what really makes it, set it above the others is the fact you've actually got a full system. So what we're going to showcase here now is we're going to show how to terminate at the top of the membrane. So for this particular install, we're using the Neuratrim termination bar that has the correct distance to cover the insulation layer. So it just sits on top there. It's screwed in, which compresses the top of the membrane. It comes down over the insulation layer, protecting it. Also, more importantly, hold that top edge of membrane for the life of the building. The top of that termination bar has what we call a wine glass design, which allows for the installation of a sealant, adds additional protection to that top edge. Katie. As Peter mentioned, this particular board has drainage capacity, but if we're in a really high hydrostatic area, we can add what we call the NeuroDrain lamp, which provides additional drainage to the system. And then that drainage will drop down to the frame. And hold this in place. Yep. Again, we can use the stick now to hold this in place. So there you go. This is a very small demonstration of the tinting system into a mock-up there. On-site conditions may vary. Awesome. Thank you very much, gents. That's appreciated. Right. Excellent. Enjoy that demo. It's a bit of a clearer demonstration of how it all goes together, other than us just talking about it. Got a couple more minutes. So just before we carry on, just one final poll there. If someone's working on a project at the moment, they want to follow up from the team, we can help them out more directly. Just feel free to click the yes button, or if you're all good, that's fine too. Just while that poll's running, just a quick save the date while we're all here. This is our last webinar for the year, hence the festive shirts. We don't always dress like this. Next year, we're having the second New Zealand Building Science Summit. We've got a date for Christchurch of the 2nd of March, Wellington the 4th of March, and Auckland on the 6th of March. Jin is going to chuck a link in the chat where you can keep an eye on that event and save the date there. We're just going to rip into the Q&A now. Like I said, if we don't get through all the questions, that's fine. They'll all come out in the transcript. So thanks, Jin. All right, let's go through the Q&A, Pete. Let's go.
I've answered some of these while you were doing the demonstration, but
liquid tanking solution.
We do. It's coming very shortly. It's primarily suited to low risk, non-habitable tanking situations like planter boxes and retaining walls.
You hear, Peter? Carry on, Pete.
How are we doing? Can you hear me? At least the technical difficulties are at the end.
Lucky last spinner.
Yep. I guess
we're all good to go. Do you have a solution for connecting a DPC to a tanking membrane?
We do. We use pressure sensitive tapes, but this is the really important thing about connecting to DPC. DPCs are damp proofing, so your connection is only going to be as good as the weakest link. So it's not a waterproof connection, it's a damp proof connection. It can still be done.
Sure. There's a quick question here about certifications. So some of our systems are CodeMark certified, some of them are Brands Appraised, some of them are both. So that helps. That's what we use to get through consent.
Yep.
So there's a question there about size of the boards that's in the TDS there. They're 600 by 1200. Sorry, a few questions here. It's great.
Someone asked, what order do you apply the Neurotherm and the drainage sheet? I think that was asked right before they got installed in the demo. It goes Neurotherm first and Neurodrain second. Yep.
Nice. Excuse me.
What happens with in situ concrete? It depends on exactly how you're doing it. It can be pre-applied, especially in blindside tanking situations. Otherwise, if you have time available for it to cure, the tanking membrane can be post-applied onto the in situ concrete. And we can advise you as to what order you would do that and which products you pick.
Quick question here around, do we need to seal the termination bar to the wall? Yes, most definitely. You might not be able to see it due to the angle we were doing the live install, but there is the top edge of that bar is tilted down at 45 degrees to allow for the application of the sealant to weatherproof that termination bar.
We didn't do it in this case because it just would have taken too long.
Yep.
But yeah, there's a PEFRON on the seal.
So.
Yep.
Is the R value affected when it's below ground? No, so the combi board is XPS, it's extremely closed cell. It does not absorb moisture. Therefore, the R value that we've given is the R value in place.
Yeah, moisture absorption rate of 0.8%. So your air spaces are going to remain closed, so the R value will stay intact.
Can you see any more there, Pete?
What are the factors that determine the tanking system type? What would trigger pre-proof versus Neuroply? It's a big question. I picked one that might
depth of the cut. Depth of the cut perhaps would sort of dictate what system we're using. If we're 9 meters below sea level on reclaimed land, we'll be going belts and braces. And we're talking about the membrane selection, but what also goes along with that, of course, is for the pre-proof, we'd be using in a very high risk situation. It would be a complete system using hydrophilic water stops, reinforced joints, water bars, all of the above, which is all part of the same system. Well, the R value of the board is 2.6. Is your fully bonded positive side waterproofing compatible with the other types, i.e. admixtures, etc.?
Yep.
Yep. So often our positive fully bonded membrane will be specified alongside some backup methods. So you'll get additives in your concrete as a kind of backup method, or sometimes they even help with reducing curing times. Like I think Markham's Conquer does a bit of that. Or they will end up using a internal applied backstop method just in case. It really depends on the situation.
Can these systems be installed in wet weather? No tanking system can be installed in wet weather. Some may say they can get away with it. Just don't risk it. It's just not worth it. You only really get one shot at it.
Yeah.
All right, so there's a fair few questions here. We're not going to get through them all today. I'm just mindful of the time. All these questions will be answered in the transcript that comes out, so they will be covered. So do appreciate your input and thank you for your participation in the polls. Like I said, this is the last webinar for the year. We'll see you again early next year. So today we talked about tanking and how we can hit that Goldilocks zone, high performance, whilst still providing a cost-conscious view on it. Thanks again for your participation. That NZIA survey will pop up at the end, and Peter and I and the team at Neuralite, we will see you early in the new year. Thank you so much. Ka kite anō.
Thanks, everyone.